Yeah, good morning, everybody. Hope you had a nice party yesterday. And really, I mean, when they put my talk at 9 o'clock after the party, I was really honored because I thought either my name or my topic will attract a lot of people. But in my head, I only have seen, like, imagined 5 people showing up at this time of the morning. So I'm really, really happy to be with you. Today we talk about, yeah, what to do with big tables in Power BI. So tables with many rows. What can we do here? As you can hear from my accent, I'm not from around. Like the first part of my last name gives you the hint that I'm from Austria, German speaker, and the last part is my wife is from Denmark. So I speak also Danish. If you want to, you can ask questions in English, Danish, or in German if you want to. Yeah, when I introduce myself, I usually tell people that I work with models. And when I do so, sometimes people have different things in mind than I have. I mean, I work with beautiful people. All of my customers and clients are beautiful, beautiful males and females. But what I get paid for is to take care of data models. And of course, this is not a beautiful data model, so there could be much of improvement. We will not talk too much about like relationships or cardinality. Today we'll talk about what we can do in the data model about how to fit big tables into Power BI and make the report still fast. So that's the idea for today. Yeah, if you like the talk, please remember to give me feedback. I will also show this afterwards. Yeah, and when we talk about big data, we speak about increasing volume, right? I mean, we live in a world where nobody deletes anything anymore, right? Everybody keeps all the data, so there's increasing volumes. There's more velocity, so data arrives faster and faster all the time, and maybe there's also greater variety when so that the data you keep track of is not structured or is the same over the time, but the structure can change. Today I'm not talking about big data, I'm talking about big tables. So big tables means huge volumes of data. Yes, more velocity, so we also have to take care of how we get the data as it arrives into the reports as fast as necessary, so real time, but real time always depends on the definition, right? Some people are happy if they have the data like on the first of the month. Other people are happy if they have it like from yesterday. Other people need it like by minutes or seconds. So this might be different for everybody. And greater variety is still a little of a problem in Power BI because we need structured tables. We need a table, we need columns. So if you have like a JSON column, it's really, really hard to make reports out of that in Power BI. So we need to put in a structure. So that's why it's grayed out. Power BI would be the wrong tool for doing that. And when you think about how to transform data and how to get it into Power BI, if you think about like really huge amounts of data, maybe we do not really want to transform the data or like store it again, but we want to keep it like in the place where it is and just have queries, complex queries in some cases, to get the data as we need it for the reports. Another idea would be, we could of course also store the query results to speed up then getting the data out, because if I run the query takes some time to do all the transformations, right? If I do this like overnight or in a background job and then just query the result, this would be much faster, of course. In some cases it makes sense, or in all cases it makes sense to enrich this data with metadata, but this means, of course, that we even take more space for the data we want to analyze. And the last one would be to store the data in different granularities. So in some cases, maybe I only want to get data by day, and if I have a table where it's aggregated by days, of course, faster to retrieve it from there instead of querying the whole fact table where every entry is available. So this would be the fourth and last idea. And those ideas I want to explore in the upcoming 47 minutes I've got. So, only storing a query definition. What does this mean? If you think about real life, this would be having a grocery list at hand, right? So if I want to eat something or I need something, I have my grocery list and I know what to buy. Which is a good idea, right? Having it at hand, so I don't have to think about what I need to buy. But to actually get the food, I have to go shopping, right? So this is not the fastest approach. If you transform this idea to data, it means that the data stays in the source system. This could be an ERP system, this could be anything. It could be a data warehouse, if you're lucky, but if you're not so lucky, it's like some application which stores the data for us. While we query the data, so for the reports, we do all the transformations we need. And usually there's a lot of transformations we need to do. Because nobody wants to see like, I don't know, codes or whatever. We need texts. yeah, we want to enrich the data. We need to calculate something, right? Just showing the number, the sales, the quantity and the price is not sufficient, right? We need to show the revenue, for example. It could be easy and complicated things. The advantage is that we don't need any extra space because the data is stored as it is in the source system, and when we need it, we query it. So from this perspective, this is a good solution also for big tables because we only query the data we need for the report. We don't transform the data or transfer the data into another place and occupy more space there. Also good is that it's always fresh, right? If you go to the grocery and shopping, you get the freshest possible fruits available for you. If you bring them home, right, they became stale minute by minute, day by day. So this is really good. I put real time under parentheses, not under double quotes, because the query runtime can be really, really slow. So at one customer, they asked me just to create reports for them. So I connected the data model, put something into the canvas, and then I waited, and I waited, and I waited, and took 10 minutes something to show up for me. If I was lucky, if I had bad luck, then an error came up, and I had a timeout issue with the analysis services tabular database in the background. And then I asked him, what's the matter here? What's wrong here? Then they told me, it's DirectQuery. And I told him, yeah, why is DirectQuery? Because it has to be real time. And I told them, it's not real time. I'm waiting 10 minutes. And if I'm bad of luck, then I don't see anything. I get an error message. This is not real time. So we really have to find a way through this. And my solution was then to load the data. Then they told me, we cannot load the data because it's too huge, right? Big tables, But it turned out, like, even when we loaded all the data, they could stick with the smallest t-shirt size of analysis services, and the queries were like this. So there were like complex things which still run 10 seconds, but before we talked about like minutes and failures. So DirectQuery can be nice, but has its backdraft, and this means the reports can be slow. And the reason why the reports can be slow is that if you put something into the canvas in Power BI Desktop, the visual does not know anything about the data. What the visual does, the visual is just a fancy DAX creator. So if you put a visual there, put something into the visual, it creates a DAX statement, sending it to the Vertipack engine, to the storage engine of Power BI, and the storage engine finds the data. And the storage engine also speaks DAX, of course. But if you're not storing anything in Power BI, the Vertipack engine discovers, oh, I don't have any data, right? But I have my grocery list. I have my recipe how to find the data in the original database. But it has to transform the DAX statement. So the DAX is converted into SQL. This is not slow, but the output, the SQL which comes out of that, is not very efficient, as you can imagine, because it's automatically generated. It's getting better and better, but still, it's automatically generated. So if you read the SQL, it's not the best SQL in some cases, even in simple circumstances. That's one of the problems. The SQL is not optimized. And the other thing is that the source system has to handle these requests. And if the source system is not an analytical database, like a data warehouse, but an ERP system, the ERP system is optimized for like putting data in, that you can maintain the addresses of your customers, that you get the invoices out, that you can keep track whatever the application does. So it's not optimized for queries. And this is an issue, right? This is an issue we can face when we have DirectQuery in place. So the query can be complex because the DAX transformed to SQL can be very, very complex. And think of, I'm not sure who in the room speaks DAX or can write DAX things. Okay, almost everybody. What about SQL? Okay, even more people, okay. So if you use to DAX, some things in DAX are really, really easy. You do a total Y to D over something, and it's like, it's a very short formula. If to try to do the same in SQL, there's like a long list of subselects or common table expressions you have to write. So alone, this leads to that the queries might be slower than expected. And also very important, at least when it comes to SQL Server, a select statement can block other operations. A select statement is just reading, but if I want to update something which is just a read, so a select statement is running, the select statement is slow because it's very complex, and during the time when the select statement runs, an update cannot happen. So the query reports, the reports we are doing, the DirectQuery reports can actually block our ERP system. And this is also a problem, right? If the customer has to wait because the invoice is not coming out of the system because somebody in the administration office does complex queries. So this is not good, I would say. And the data in the source system must be available in the business hours, because usually like people in the offices work at the same time like people in the retail shops or whatever. So there's like a challenge to satisfy both things, right? We want to write to the tables, we want to read from the tables. And also, some systems might not really store everything, right? They might like decide we want to clean up. Right? I don't need the invoices from 10 years ago anymore, so they delete this in the ERP system. But somebody for the reports still needs the data, and it's gone. So if it's not stored extra. And some things are just not possible. Think of slowly changing dimension. Who knows about slowly changing dimensions? Okay, oh, half the room again. So this is like keeping track of history changes of the dimension of your filters. Like if a customer moves around and moves from one region to another region, maybe it's okay if you store just the latest region and all the reports, all the revenues go to the latest region, even like from years before. Or you want to keep track of this, and slowly changing dimension is the concept to solve this. This is not possible if the source system does not keep changes of this, does not keep track of these changes. In a data warehouse, this is not an issue. If you copy the data, we can implement this for you. Yeah, of course, there could also other limitations of the query interface, whatever the source system allows us to query and get. And to implement this grocery list, you would like have DirectQuery in Power BI or analysis services, or have a view in SQL Server. So if you're into SQL, of course, you can also think about not storing things, just putting a view on top of a complex query, and then expose the view to the report tool or to whatever. Let's see how DirectQuery mode works. Let's go to this demo. And what we're seeing here is on the left, we see there's a date table, and I extra named it DirectQuery to remind me this is in DirectQuery mode, because I have a data model which is a little bit weird. I have like the date table multiple times in here in different modes just to demonstrate. Yeah? Please don't do this at home. Don't build a data model where you try all the storage modes. It's just for educational purposes here. And I also have the reseller sales table also in DirectQuery mode. It was too long, so that's why I shortcutted it to DQ. And as you can see here, we have the date table here with the date and the year. Very simple report, reseller sales, and the reseller sales contains the date from the date table. Can everybody read this? If not, please let me know. Especially in the back of the room, because usually the people in the front of the room say, yeah, we can read it. In the back, everything is fine. Very good. And the sum of the sales amount is like coming from the reseller sales table. So I'm combining two things from the DirectQuery table. And you don't have to believe me that this is the output. So let's start the view here and turn on the performance analyzer. I'm a little bit confused because the screen resolution is different to make your experience better. But my experience is a little bit weird now. So refresh visuals, and as we can see here, the reseller DQ, that's the table we just have seen with the combination, took 1 second, so 1,000 milliseconds to execute. And as you can see here, there's a DAX query because the visual generates a DAX query, but this DAX query is then generated into SQL. So that's why we see also DirectQuery in here. And if I copy this query and then use my external tools and DAX Studio, who does not know DAX Studio? Nobody dares to okay, some show hand. If you're serious into writing DAX and optimizing your data model, there's no way around DAX Studio. I mean, we have now this DAX query view in Power BI Desktop, but there's many things you can do with DAX Studio you can't do with Power BI Desktop. So please check out DAX Studio if you haven't never heard about it. And what we can do here is that I can then enter my query here. Again, screen resolution is a little bit weird for me. And as you can see here, the DAX query, that's the DAX query generated by the visual, by the table. So it's like evaluating this variable, and the variable is the top 501 rows from this variable over the dates. And this variable is like a summarize over the dates for my calculate sum of sales amount. This is easy to read, right? If you transform this to SQL, it's a little bit more complex. It's like this query, right? We're doing a select over the date and the sum of the sales amount from one thing is that it's combining then the fact reseller sales table and joining it with the date table, dim date table here. So that's it. Group by, and then there's a where, order by. Much more code like, but still very simple thing. To get rid of those backdrafts with DirectQuery, because queries might be slow, it might be put too much pressure on the source system, we could store the results, right? This is like doing the shopping and having like a food storage room where you put the groceries. So if you're hungry, you don't have to go shopping, but you have it like closer to you in the food storage room. In the sense of data, it means that we duplicate the data. And when I started like data warehousing in 2006, I thought this is a really good idea. I mean, we're duplicating things, right? I learned when I started like 30 years ago my education about data modeling. Normalizing was very important to get rid of redundancy. We do not have duplicate things. And with data warehouses, we have this like denormalized dimension tables. This is like still giving me shivers if I think about what my reaction was. Why would you do that? And we're duplicating not only having redundant tables, but we're duplicating everything again in the data warehouse. Why would you do that, right? And the reason is to speed up things for the analytics, to speed up things in the reports, to make things possible which are not possible when you're directly querying the source system. And when we duplicate things, of course, we have also to take care that the duplicated data is still fresh. So we have scheduled refreshes. So we need somebody either presses refresh in Power BI Desktop and republishes the report or share the PBX file, or have something more fancy in the background system where we run scheduled jobs to update the data warehouse or update then and refresh the semantic model. And of course, this means we need extra space. So we need to buy, I don't know, Fabric. We do need to buy a SQL Azure DB to host the data. We need to buy some metal if we want to keep it on premises, for example. So there's cost attached, of course. In the case of Power BI, the size we need is not that huge because it's heavily compressed. Usually the rule of thumb is 1/10. So 200 gigabytes of data warehouse compresses to 20 gigabytes of Power BI. Still a lot. The other background is that the report data is always stale, because as soon as the refresh is finished, right, the data can change, the data will change, and I don't see these changes reflected in Power BI. So I'm always a little bit behind. The question is, how much being behind is okay? As I mentioned in the introduction, maybe once a month, once a week, once a day, every 10 minutes, every hour. This depends on the use cases, of course. So real time is different for everybody. And the reports will be much faster, of course, because we're not doing transformations and complex queries on the fly, but we just do a very simple query over the data we already have prepared, where all the transformations are already done. The reports are in cache, so to speak. So if you import data to Power BI, everything is in memory in Power BI Desktop. So this is the fastest way to get the data, right? We don't have to query a database somewhere in the network or over the internet, but we have everything on the laptop in memory. I mean, that's the fastest thing we can do. And also WordyPack is a really fast engine. I'm biased, yes, but I tend to say that WordyPack is the fastest query engine on the planet. It's really, really fast to satisfy your queries. And all the complexity we're doing for the transformations is done in the backend, in the night job, during the refresh. But when I then need to show the data in the report, it's really, really fast. So we're moving responsibilities of transformations. And when the source system is turned off, for example, I also do like data warehouses projects where the only use case for the data warehouse is to satisfy the data for Power BI. So there's one refresh in the night. I implement this as an Azure SQL DB serverless, which turns off after 1 hour. So I can even with a small budget, we can have a huge Azure SQL DB because it's only running 1 hour a day, where we load the data into the data warehouse, build views, load and refresh them Power BI Desktop, and then the machine turns off again. So this is really, really easy to do because we don't need the data warehouse being active throughout the day when people run queries against Power BI or the semantic model. And we have a lot of choices, right? Because if you do DirectQuery, everything has to fit into SQL statement. So everything which we can write in SQL, what we can do in SQL, we can do, but there's no other choice. If you persist the data anywhere, you can use any of your tools. If you want to write Python notebooks, be my guest. If you use Spark, SQL, Azure data flows, Power Query, whatever. Yeah? There's no limits what kind of tooling you're using to transform the data in a way that it's optimized for the usage in Power BI or in the semantic model. Usually, the data is not just transformed, but also enriched. So like we pre-cook something, right? A little bit extra effort, right? You're doing the grocery and then we pre-cook something or prepare, making the kitchen ready, clean up the vegetables or whatever, and put in the refrigerator. That means before we finished, we need to do a little bit more extra steps, but when we want to cook or eat, it's much faster. That's the idea of metadata, right? So In the case of a SQL database, you would think about an index strategy, for example. If it's not a clustered but a non-clustered index, it means that, again, it's extra storage you're using. In the case of a semantic model, think of measures or think of other things, relationships. Some of them use space, like the relationships take up some space in your semantic model. The measures don't, right? Except for the duck statement. And of course, then the queries, like the transformations, will take more time because then we load the data into the table and also the index has to be updated and maintained. So the write operation will take a bit longer. So we're exchanging resources here. But in the end, read operations will be much faster because they can depend on an index fitting and finding the data much faster. Yeah, you also need extra space for this, unless there's compression, right? Think of an non-clustered or clustered column store index. It's the same strategy or the same idea like the Vertipack engine in Power BI. This is also highly compressed, so this index does not cost as much as you might think because it's highly compressed. And the idea is to have everything faster at hand, so when I need the data, it's much faster. For example, we import the data to Power BI or the semantic model, or we put indexes on an Azure SQL DB. So let's take a look how this looks like in Power BI. So if we do import mode, let's get rid of this first. The same example, right? Because I want to keep like the demo simple, just so we can concentrate on the technology. So the same example, I have a date table, I have a reseller sales table, and both are in input mode now, right? So for the reseller sales, again, for this visual, I again have the date table here from the imported date table, and then I have the sales amount from the imported full load reseller sales table. If we run the performance analyzer here, again, don't have to trust me that this is right. I refresh the visuals. This is much faster, right? Before it was like 1,000 milliseconds. Now it's under 200 milliseconds. Maybe the end users will not care because everything under 1 second, nobody cares. It's fast, right? But what we can see here is that only a DAX query is evaluated, and there's no direct query, right? And if I copy this again to my beloved DAX Studio, then we can see there's only this DAX query again with the summarize over the group by date table sum of the sales amount. The top N is done, and that's it. There's no direct query. That's why it's fast. It hasn't been transformed into SQL. No SQL is run against a SQL database anywhere in my network or in the cloud. Everything is locally run in this Power BI desktop. If there's any questions, please just interrupt me, of course. Yeah, there's a question. Yeah? How many rows do I have in the fact table? In this concrete example, it's 60,000 rows. It's like very tiny. It's just, I mean, I could easily make this bigger, but of course the direct query demo would then take minutes, and I do not want to spend time. This is an excuse here, so please believe me, this also works with millions, trillions of data, right? And this is exactly what the over next slide will talk about. What's too big, right? This is maybe the question. So 60,000 rows, of course this fast, right? In direct query and input mode, but where is the trade-off? That's what I assume from this question. Where is the point where I cannot load it, right? Yeah, and I will come to this slide in the over next slide. So it's a perfect question, right? If I'm prepared for the question anyways, that's the perfect question for a speaker. So to sum it up, like one thing, on the one hand we have direct query, that's the grocery list, right? We don't move the data stays unharmed in the remote database where it is stored anyways. We do ad hoc queries as we need for the reports. We query this data, and we have this backdraft of the DAX queries must be converted to SQL. That's the reason why direct query is not possible over all your data, right? There's no way of having direct query over an Excel spreadsheet because Excel doesn't speak any query languages or a CSV file. SQL does. SAP HANA, I think, does. I don't have it in my mind currently. Like there's 5-6 data sources which allow you to do direct query. But this should be the exception. And I believe Marco Russo like mentioned this once. He thinks that like DirectQuery was just a bad naming because DirectQuery thinks, oh, I'm directly querying something. I don't have to move something. It should be fast. It's real time. It's perfect. No, it's not. DirectQuery should have been named no cache. If it's named no cache, nobody would use it, right? But of course, you want to cache things. You want to speedy reports. You want to have like happy faces with your report users and not slow reports. So that's the grocery list. The import mode means that we have to take the data from somewhere, compress it, store it in memory. So we need extra resources doing the compression, storing it anywhere. We need regular refreshes, otherwise the data is stale. The good thing is the DAX query is run natively because the WordPack engine speaks and understands DAX. So everything coming from the visuals is directly going there. And this should be the default. And this is the pre-cooked meal. And I did a table talk at the Global Fabric Power BI Summit from Resorat a couple of weeks ago, and I did a table talk there, and also we did about a talk about data modeling. And there was also like questions. You know, my data is just too big to fit into Power BI. We cannot load it. And then we asked this person, how big is it? And he said, yeah, it's huge, it's huge. Yeah, how many rows? Yeah, really many rows. Yeah, how many rows? 1 million rows. And 1 million rows is huge for Power BI, for Excel, right? 1 million rows is huge for us to read a table and understand what's going there. But 1 million rows is tiny for Power BI and the semantic model. If you read about like the internals of this WordPack engine, it stores, it's called WordPack engine because it stores like all the columns separately, and all the rows are grouped into segments. And one segment in Power BI Desktop is 1 million rows. So one of the tricks to speed up things is segment elimination. So it's, Power BI knows what kind of data is within the segment, like what kind of customer keys, for example. And I'm looking for a special customer key. It knows that like in this segment, this customer is not mentioned. So it can like eliminate this segment. But if you only have up to 1 million rows, the segment elimination does not even work because everything fits in one segment. And anybody using like the large data models in Power BI Service? Yeah, few hands, 5, 6 hands. This means that it transforms the size of segments from 1 million to 8 million rows because this is the sweet spot for the WordPack engine. Just for Power BI Desktop for self-service, they thought it's better with 1 million rows, but in the large models, it's 8 million rows. Also in analysis services, if you're using analysis services tabular or Azure analysis services, the segment size is 8 million rows. So everything above the segment size starts to be like something, right? So if you have many segments, then we're talking about huge models. But 1 million rows is not an issue. So there's examples with billions of rows. When it comes to trillion of rows, then we can come into problems. And it's not so much the number of rows, it's more like the number of the general size, right? If you think about Power BI, if you want to use Power BI Service, in Pro you only have is it 1 gigabyte, 10 gigabytes, something like this. But with Premium it's up to 400 gigabytes, but in the P1 it's just 25 gigabytes of compressed data. So this is the issue. It's not so much like the number of rows, maybe. Yeah. So what can we do if we load millions of rows every time? The refresh will take too long. This is one of the problems we're facing, and we can solve this with incremental refresh. So we're not eating everything at once, but eat or cook things in smaller portions. By default, Power BI does a full refresh, and the reason is clear because it's the easiest way. Full refresh means Power BI already has everything in the semantic model. I'm doing the full refresh. It's taking up another portion of the memory and loading everything in there, doing all the transformations. And if it's finished, every request is pointed to the new version of it, and the old version is discarded. That's why if you implement analysis services, you need 2 to 2.5 size of your end model as the memory available. Otherwise, the refresh cannot run through. In Power BI Service, I think it's not an issue. So the 25 gigabytes only count for your model. So the rest of the memory is for free, maybe. And easy to implement, right? We just build up everything and then discard the old version and move over to the new version. If you want to make this more smart, of course, you have to think about the logic. The incremental refresh means that we only know the new data. So we have to identify what's new and what do we have to refresh. So we have a more complex logic. We need to identify in the source system what's new. And the modified date is not a good idea. Modified date means that a row could move between partitions, right? So what's it doing, the incremental refresh, is building up partitions. So per timestamp, per day, puts everything together in partitions. And if the graded date, this should be like, this would be a good thing, because the graded date moves something into one partition and stays there. If it's the modified date, it would mean that it's modified like a week ago, so it's in the partition for a week ago. Then you change the modified date, and then it would move like in the partition for yesterday, and then you would have it twice in your system. So this would not be a good candidate for, would be a wrong candidate. Yeah, there's a question here. What do you do about deleted records in the source system? When you know that something is deleted there, then you have to find out and manually refresh this partition. So the incremental refresh cannot take care of that. I would also say something, deletion is a very rare, in my business cases, deletion is a very rare thing, because nobody deletes anything. It's maybe it's a soft delete, marked as deleted, so it has to be ignored in the reports, but physically it's not deleted. But if this is the case, incremental refresh, the automatic version, will not work for you. You have to keep track of partitions where something was deleted, and then manually refresh those partitions. There's also a manual way of doing this, the things. Does this answer my question? So, and Carola has to wait, unfortunately. I am busy. Yeah, of course, yeah, we need some space, and yeah, the space used and the performance will not change with this. And there's this built-in logic, which I will demonstrate, and also the other one, we can also manually take care of partitions. So in Power BI Premium, you need Power BI Premium for the incremental refresh. You can also manually create and maintain the partitions, and then refresh not the whole data model or the whole table, but identify which partitions you want to refresh. And this is also what I did for one of my customers with the problem there. There was an Oracle system. They wanted to do the reports in Power BI, and they tried out DirectQuery, and this was like taking too long. Refreshing was also taking too long. So the compromise was implement something on the Oracle side that we know which kind of partitions changes had happened, and then the automatical trigger running every 10 minutes identified which partitions were changed and refreshed only those partitions. So there's a bit of a logic, of course. You have to sit down and find a way and try out what's performance-wise possible, technology-wise possible. But there's ways there. It's not like out of the box, unfortunately. But this could be a good compromise to have everything loaded, but still the refresh time is not taking too long. Yeah, there's another question. How did I implement this with REST API? No, I just used the XML point. So XML is the XML, the extensible markup language for analysis services. I will just demonstrate, again, perfect question. I will show the XML endpoint. We can get this XML command and then run things, creating or maintaining the partitions or refreshing them. I'm doing time-wise, 20 minutes to go. Yeah. Let's see how this works. So the incremental refresh. If I'm jumping here, again, get rid of these things. That's the incremental refresh. Again, reseller sales table loaded multiple times in the model. Don't do this at home. And in this version, if I click here on this context menu, you see one of the options, the incremental refresh. This is what Power BI helps you to take care of the partitions. And now we're getting asked what we want to do, right? In this example, I told it, I want to implement this incremental refresh for this table, reseller sales incremental refresh. Then you can decide on, do you really want to keep everything in this table? So maybe data 10 years old is not of interest, or 5 years old, maybe. Yes? Then you put in here, I only want to keep like the last year. That's what I did here, before the refresh date. Everything older is discarded from the table. So be careful with that, because this will be missed in the reports. And the incremental refresh then, usually is like 3 days, 7 days, whatever. I did 120 days in here, because the 20 regs table I'm using here can have older data, right? That's the thing here. So for the last 120 days, they will always be refreshed. So if I refresh the data model, the last 100 days will be refreshed. Everything older than 120 will not be refreshed. Everything older than a year will be discarded from the table. Then also you can decide if you want to have like only complete days. For business analytics, is often that they expect that like they have full days and not like half days, because then they're wondering why the revenue is so low for this day, and they discover, oh, it's just like before lunch, right? So this might be a good option. And if it should detect the data changes, and then we have to provide where you can find the column to identify in which partition the data has to be moved. That's the data change. Also to implement this, and we get a nice tree view here. That means everything like 1 year before is archived, everything like 1 year is not used, right? The rest is archived, so not changing anymore. Everything within the 120 days frame is in the incremental refresh. To also have Power BI here, we also need to go and go into the data model here so Power BI needs a way to only load the data for a certain day, right? So how can it find out how this is done? So what you need to implement is you have to have two parameters, Power Query parameters, range start and range end. They have to be named exactly like this, no blank, no other names, because this is what Power BI service uses to communicate with the model and tell it, please refresh for this 1 day, because this is what I need in this partition. And in the table itself, you have to have a filter in there which takes care of these two ranges, right? So you have to put a filter where you ask for that you can't see the table here, right? The order date is after or equal to the range date, or it's before and equal to the range end. So it has to be included in here. If I do so now I'm using again, not again, but I'm jumping back to Power BI. External tools, now I'm using Table Editor. Let's take Table Editor 3. Table Editor 2 is a free tool maintained by Daniel Ottik here. Like DAX Studio is also a free tool by Darren Gospel. And they also have a booth here. So if you want to check out the paid version where you also get support and a lot of other nice features. And I should update it here again. So I have my table here and I have my reseller sales incremental refresh. So after I've implemented this, and now I'm stuck here, where do I see the partitions? Reseller sales, incremental refresh. Here, the partitions. So when you implement this, there's only one partition, because Power BI Desktop ignores this setting. This is only available in Power BI Service. So there's only one partition created, but if you publish the report and then synchronize it, then you will see, and this is what I'm having here somewhere. So I'm connected to my workspace. So with this URL Power BI API powerbi.com version 1 my.org/name of your workspace. So PPU is the name of my workspace. This is like the server for the databases, and all your semantic models are named as databases in here. And in my big table example, I published this, I did a refresh. So in order you don't have to wait for it, if you take a look on this refresh thing and I right-click here, asking for the partitions, we can see there's a lot of partitions created automatically now by Power BI, by the Power BI service. So it's taking care of all the partitioning, removing partitions, modifying the partitions, creating the new partitions. And as you can see here, there's one for quarter 2023 with this number of rows, and I did this back 2 weeks ago. So like the most current thing was from 11th of March. If I run the refresh now, it will create something for yesterday, because I asked for full days, not for today. Okay, makes sense? And I can run these partitions also here. I can also ask for, please script, not here, process table, I think it's in this. And then I get a script from here. So I can ask for a script. One thing is to refresh things. For example, the script looks like this. So that's XMLR. I would not be able to write this down with my fingers, but like using Management Studio is really easy here. Obviously, there's a refresh command, and it should like decide itself how to do the refresh, a full refresh, only the data, whatever, about the table, this database or this table. And I just enter, at the very end, I can just enter that I want to do the partition, and then name the name of the partition. F5, and this is a command. It looks like a file, or a CSV file, or XML file, but this is a command where we can set up things. And the same is true if you want to create partitions. So if I again go here to partitions, and maybe I want to script this one, so I get the definition for this partition. I get the XML command, which is create or replace, again, in the database, big table, in the table, blah, 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 the partition, and then it tells me, or tells here how this is created. And this is what you can also implement on yourself. So implement a logic where you find out what kind of partitions do I need. Do I need to merge partitions? Do I need split partitions? Do I need new partitions? And then refresh the thing. Very important, if you do it on yourself, please make sure that you don't have overlapping things, overlapping partitions. Otherwise, data will be duplicated in there. Hard to discover usually, or something will be missing if you have gaps. So please test this as good as possible. Okay, so the next thing is composite model. Maybe you say, yeah, the dimension tables, they are small, right? I want to import them, but the fact table is just too big. And there's a way for doing this. So we can combine things. You can have a composite model means one data model, one semantic model, where part of the tables, some of the tables is in import mode, other tables is in DirectQuery mode. And Power BI also allows you this. As I only got 10 minutes to go, I will a little bit speed up. I already talk fast, I know, but I have to speed up a little bit more here. So less space used because we only store the smaller dimension tables. The reports can be slower or faster, so depending on how this is running, as we can see in this demo. So what we can see here is in here. If I jump over to my composite model, so I have now the date table I use for from imported, right? I have this report here. We have the date table from an imported table. So the date table is imported, but the sales amount is coming from fact resource sales, which is in DirectQuery mode. So I'm combining two different data sources in my report. Easy to do because we just input something, have a DirectQuery table there, connect this in the data model. So from a user perspective, this is easy. But behind the scenes, this is rather complex what has to be done, because now we combine things from different sources, which are not combinable in both places, right? So if I run again my performance analyzer, start recording, refresh the thing, of course, we expect that we get again 1 second of runtime. We get this DirectQuery here, and if I copy the query and put it into my DAX Studio, I think that's the wrong DAX Studio. Come here again. I'm not running it. It's not that important where I put it. No, this is the other thing. Table editor, yeah, thank you, Maria, but I'm just stuck in my, I don't have DAX Studio because I think I'm jumping between my demo machine and here. That's the thing, I guess. Is it? I'm running out of time and now I'm not finding my demos. That's very interesting. So, there it was. Where it is? I can't see it. Here it is. Thank you very much. So, again, the big table, putting things in here. So what you get, again, is the DAX part is rather easy, right? DAX part is the unchanged. It's the same thing we already have seen. We have this summarized column over the date and the sum of the sales amount, same thing, because the visual creates the same thing. It doesn't know anything about DirectQuery composite model. But what the Vertebrate engine does is it now has to do the date table, some weird aliases, right? And the order date. The order date comes from the fact resource sales table, which is here, and then joining, and now it's getting interesting. It cannot join with the date table because the date table doesn't sit on the SQL side of things, but the date table sits inside of Power BI. So how does it can combine those things? It injects all the data here. So we get an inner join over a subquery, and the subquery contains all the data. So if you do composite models, sometimes you see like this warning that there could be data exposed. And the thing is exactly this one. So if you have like a secret list of things stored in Power BI, combining it in DirectQuery mode with another table, then the secret things might be injected in the query text sent over to the database. So a database administrator who is not allowed to see the data you're hosting in Power BI can see the query text and therefore can see the data. So think about it. This can be something dangerous for your data. Doesn't have to be, but that's the reason for the warning. So, and this is the reason why the query maybe is much slower now, because having this long list of common table expressions or subqueries can slow down the query, of course. Then we can also combine, we really have to speed up, the dual mode. Dual mode that we have one table, and the one table is in both import mode and DirectQuery mode. That means I can either use it with the imported data, or I can use it with the DirectQuery data. So again, jumping over to the demo, which is much more fun to explain the things. So I have one table here, where I have the date table now in dual mode, and the result is still in DirectQuery mode. And as the date table is in dual mode, it means that both the data is loaded, but also the grocery list, how to get the data from the source system, is also stored there. And Power BI decides then ad hoc, oh, I'm combining something from a DirectQuery source with something which is in dual mode, so I have also the grocery list. So it can be run as one query. So now it does, and just keep here, so I'm not starting anything and getting confused myself, is that it now knows that the order table is also available in the source system. So it's not injecting the content of the order table as a subquery, but now it knows, I can combine this directly, and the join is directly run on the SQL Server side of things. On the other hand, if I combine the same date table in dual mode with another table, which is also loaded, Power BI discovers, oh, both are loaded, so I have no need to use any DirectQuery, but put only a DAX statement and combine everything locally in memory. So that's the idea of a dual mode. So if you have composite model, maybe it makes sense that you put all the tables which have connection both to imported data and to DirectQuery data, you should put those tables into dual mode. So with every refresh, they are refreshed, but also the grocery list is kept, so it can be combined. There's a question online. Yes, please. The question is, can you set up a scheduled refresh for incremental refresh? Yes. If the table is, if you implemented this incremental refresh, every refresh means that this table is only incrementally refreshed. So in Power BI service, if you start the refresh, it's only doing the incremental refresh for this one table and the full refresh for all the other tables. So this is automatically done for you. Hope this answers the questions. Okay, 5 minutes to go. And there's still 2 demos I want to show, right? So there's also the hybrid mode. So hybrid mode, and this can confuse people, because dual mode means that the table is in both imported and DirectQuery. Hybrid means the same, but it means that some of the rows of the table is in import mode, other rows of the table is in DirectQuery mode. So the table is not both imported in DirectQuery, but depending on the partition, some of the partitions are in import mode, some of the partitions in hybrid mode. And the thing which Power BI does assist is the first one. I can have like the most recent data I keep in DirectQuery mode. So if anybody looks up for the data for today, they get DirectQuery real time. Everything they look up for like last week, this is ultra fast because this is imported. And I assume that nothing changes for the past. And you implement this rather easily with the same dialog you have seen with the incremental refresh. So you go to the other example. I already clicked the right buttons. So again, this is no, not here. Then I'll take this one. Not very picky at this point in time. That's interesting. You just have seen this, right? Incremental refresh. Okay, I turn it on here again. So I fill out again. I want to have like the last year, whatever. I want to have like the 7 days incrementally refreshed, and then you can click this button here, get the latest data in real time with DirectQuery. That means that the last 7 days, they are, no, it's only them, is it? I'm doubting myself. Like some of the partitions, like the last partitions, will be in DirectQuery mode. That means that this might be slower, right? Now everything after the refresh date. So after refresh, everything is loaded, right? But the most current thing, which is newer than the last refresh date, will be in DirectQuery mode. So we can combine DirectQuery real-time with fast performance by refreshing the data as well. Of course, you could also talk about another solution where we take this the other way around. That we say, of course, the most current things I want to keep imported because this is the things queried all of the times. And everything older, I want a DirectQuery mode because I do not want to load this to Vertipack engine. I want to keep this at the data source. So people can still query it, but they know if it's like 2 years old, it will take longer because this diverts to DirectQuery. For the last solution, you cannot do this with this dialog for incremental refresh, but you have to come up with your own partitions. And there's only 1 minute to go. I have really to skip the last idea, which is aggregation tables. So you can have like different aggregation tables. That means that you load the data, like you have one table in DirectQuery mode with the most granular thing, and then you have an aggregated table where you aggregate things by date, for example. And then Power BI can decide for you, I'm only looking at dates, right? So I'm taking everything from the aggregation table, blazing fast. If somebody moves also like the the I don't know, the sales order number, then it's traversing to DirectQuery and takes longer. And Power BI takes care of this. But this is only possible if the fact table is in DirectQuery mode and the other one is imported mode. Again, if you want to have more complex things, you can decide on your own in a measure. You can have an if statement in a measure, deciding on in which cases I take the aggregation from this table or the other tables. And I'm out of time, I know. So you get all the slides. Remember, there's a lot of storage modes that might be confusing sometimes. Import is always the best. Try to import the data because it's much better than everything else. If you liked it, please give me feedback, of course, and then I will be around for questions, of course. Thank you very much. Have a nice Saturday at Gigabits.